Nope. Nope.
Wow, there it is. In case anyone was wondering what the first YouTube video streamed over V6 was. Yeah, now you can sleep at night. Thank you all for coming back this early in the morning. I hope everything is still going well. If there's a problem with anything, don't find me or find Sabrina, and we'll try to get it taken care of. And I think we should just start, right? This morning we're starting with a vendor roadmap presentation. So get your vendor questions ready. Don't be afraid to ask hard questions. And to suffer the first slings and arrows of outrageous fortune is Mark Townsley from Cisco.
Thanks, Eric. I don't know what I'll use. Let's see. Usually like to move around. Try to keep up with. Do the karaoke thing. Does this one work too? Good. So yeah, that was Yip Yip. And we had the TCP dump down here, knowing that we were actually doing V6. I had a lot of fun at the Barcelona Networkers several months ago. I had the opportunity to do a preview just a few hours before these guys released the Quad A's to the world, and the first public video streamed over YouTube was of Itogen. And this is something that Eric really wanted to have done, and it was a really moving moment if some of you might have been there. After that was Eric actually streaming in saying hello from Japan, which is where he was. And then we had a discussion about IPv6 deployments, several hundred people there. And then they talked a lot about eating dog food. And I just found that while everybody else was giving their presentations, I was like, well, YouTube. Okay, I had this little IPv6 YouTube thing, my Mac and nobody else in the world, right? Privately looking, I was like, okay, this is a good one, and played it at the end, and it was pretty funny. Thank you very much, Randy, because that leads me right to my next piece, dog food. Did you see that, Randy? That's not through a translator. That's dual stack from UCS servers on San Jose campus. Manny? Where's Manny? Manny from our IT department did this with his team. Actually, stand up so I can knock you down. It's actually a Lisp connection, and you can go beat up Dino for that. The setup we have now is actually quite similar to what Don was talking about yesterday in terms of Lisp, dual Lisp connections, so on and so forth. We go out here native v6 and in the Palo Alto Exchange pick up the Lisp tunnel servers into our data center. The target plan for this to go live, so that right now, again, like in Barcelona, just this Mac can do this, right? There's not a DNS entry for this. In fact, there's an ACL on this Mac. Boo, I know. But I'll tell you why, and there's an interesting twist. So the plan for this to be available for everyone is end of July. But I went to these guys and said, hey, let me do a preview in advance, right? And the reason for the ACL was because the InfoSec policy guys hadn't, reviewed it, whatever, and they were just like, okay, if you can just restrict it just to your laptop. Sure, I can do that. This is IPv6. If it had been IPv4, it would have been impossible, right? So you start to see, okay, oh, you mean you'll have a static IP address? That's really cool, because normally, if this had been IPv4, I would have just been NATed, and what they asked for from a security perspective would have been effectively impossible. So it actually illustrated something to our IT guys, to our security guys, something you can do with IPv6 that you can't do with IPv4. I was happy to do it, fine. In a month, it goes away anyway, right? So I can poke around here for a little while. Cisco's got lots and lots of products. In fact, I wanted to kind of do a overview of the IPv6 readiness across our entire portfolio. So I looked at our price list, and I did a cat WC minus L, whatever. There's 178,000 entries in our price list. That's a rough job. So instead, I'll be showing you, in the short amount of time I have, some of the new implementation strategies that we're bringing into Cisco, whether it's from the grassroots, like you saw from Bob yesterday, or from the top down. And in fact, somebody was so excited that we were doing this, they wanted to have something to say. Now, it didn't load because it's in my cache. Gotta load over v6. Reload, still in my cache. Doggone it. Developer, disable caches. Don't know why it's still in the cache. Hold on. There we go. Loading, over v6, over v6, over v6. Didn't hear you, Randy. All right.
Hello, I'm John Chambers, Chairman and CEO of Cisco. And it's a pleasure to be one of the participants along with Mark here at Google's IPv6 Implementation Conference. All of us have seen the tremendous explosive growth of the internet over the last 2 decades. And while many of the expectations of the internet people thought were stretched too far at a point in time, almost without exception, we overcome those expectations in a shorter time period than many people anticipate. I think it's very important for all of us to realize that if we don't overcome the challenges of IPv4 in a quick time period, we will slow down the growth of the internet and actually lose momentum as an industry. IPv6 is important to all of us, not just to Cisco or to Google, but to everyone around the world. It's crucial to our ability to tie together everyone and every device. At Cisco, we're committed architecturally across the board. All of our devices, all of our applications, all of our services. We've been a very active member in many of the focus groups in this area, both with our customers and IETF, etc. And it is the importance of understanding how rapidly the internet is changing every aspect of our lives. Not just changing the way you work, live, learn, and play, but changing business models, changing the way government delivers services, changing the way we deliver health care or education of our children, how service providers completely change their model in terms of the value they bring, and how content providers literally make a difference for all of us, both in our entertainment and our business lives. One of the things we're very proud of at Cisco is we've always been leading in terms of a partnership for doing what's right for the industry, as well as what's right for our company. I think we are in complete agreement in terms of the important thought leadership of IPv6. You will see this in every one of our products, as I mentioned earlier, every router, every switch, all of our core iOS software, and we will expand it into the services such as security and management. We also focus with literally 100 of our largest customers in US and Europe on an IPv6 development council. To say we're committed is an understatement. To say that we will partner for life on this one is exactly what we'll do together to bring the industry leadership here. And all of us will focus on how we use this, not just in terms of what we say and build it into our products, but even how we do this preview today with this video over IPv6 and building this off of our new server technology at our San Jose campus, the UCS. So we do this, we walk the walk, we walk the talk, but we'll do it together as a team. But for it to be successful, it requires the industry collaboration. I want to thank Google for playing such a key role in helping to make that happen. We are completely committed to a common view of the future. And while there'll be challenges as we achieve that common goal, and there's a lot more to do, there will be bumps in the road. I think together we can really make a difference. This conference gets us a step closer. So enjoy the session, and Mark, back to you.
So at Cisco, we've had a foundation of a lot, years and years of people working on IPv6. The US GV6 programs that Thomas was talking about the other day has been a driver. The work that DREN does, the 100 customers in our deployment council that John Chambers referred to. These are customers that we meet with by telepresence every quarter in different geographies around the world and talk with you, the early adopters, the people that are deploying right now or about to deploy. And if you're not in that, some of you I know from that, if you're not in that, let me know, and we'll work with your account teams to get you involved. So we want to work with you very, very closely here. So that's the foundation, but we've got new stuff coming as well. But back to dog food. Let me get to the presentation here. That was the end. This is what you just saw, by the way. That's sort of the network diagram, right? We pulled off IPv6.cisco.com. We've dual stacked it. It's running essentially a copy of the entire branch right now, okay? So let us, an entire tree, an entire content to let us play around. Just like, oh, thank you. Just like with Facebook, there's some stuff that goes over to v4 if there's a redirect or whatever. And I want you guys to talk about some of the tricks that he was talking about the other day. I wanted a lapel mic for a reason. Okay. Anyhow. So here's IT's deployment plan, very, very loose, no dates here, but it is a plan. It's underway. It's official. It's not, Gunter and Eric Vink going in and hacking things up. This is from our IT department, and this is something that internally within Cisco we've been wanting for a long time, and it's underway, and I'm really happy about that. And the Cisco.com preview that you've seen, it's not a demo, it's a preview. This is the exact actual servers that are going to be used next month when we go online, similar to all the other IPv6.foobar.coms, and then eventually folded into www. So I talked about implementation strategy. You guys want to know how you're going to get these products, out, and how we're going to reach that wonderful utopia of parity. Again, the foundation. 10 years of standardization and writing code. We've got a lot of code under there, but a lot of it is very, very product focused, right? Whether it's your checklist that you're trying to meet or one specific product because, one specific account is coming in with, with a lot of money or what have you, and we develop this feature. It's very product focused, but we're moving to what we already have started is a systems-based approach, okay? Where we go and we look at how you're deploying IPv6 and identify not only the particular features that we have to implement in order to bridge those gaps, but developing new technologies to bridge the gap across areas of the network that just aren't ready for IPv6. You've heard a lot about 6RD yesterday, those kinds of things, right? Get the traffic moving. So that's one of the parallel tracks. That's the second one up there. The third is really about culture change, process change, okay? This is where the engineer who's writing the code has IPv6 available because we've deployed it on our campus, right? Knows what IPv6 is because we have a training program that helped them know what IPv6 is and just codes it by default, okay? And that's how we target new code, okay? New development, right? So the idea is you've got lots of code out there. We're going to target, we're going to prioritize. Someone at the mic yesterday asked, how do you know what to do first? Well, that's how we're going to know what to do first, right? And at the same time, you heard it from the man from the top, bring in process change, okay? So that no new features go out, no new products go out without IPv6 in them, okay? Now, that's not going to happen overnight, but we've already got, VPs of product lines signing up for that. So I talked a little bit about deployment strategies. We have tailored deployment strategies that drive our development tailored to the markets that we serve. We serve lots of markets, okay? Here's 5 of them that are important. Service provider at the top, right? We got to get the users connected. Content, of course. Frankly, content, we're watching you. We're watching Google. We're watching Facebook. We're doing it ourselves, right? That's how we're learning what to prioritize. And we know we've got some holes there. Public sector, we've got the lists that Thomas talked about, right? They are very clear what they want, right? But you've also got the smart grids and the sensors and these kinds of things. It's a different market because they are so clear in their IPv6 requirements. In enterprise, it's a little bit different. I'll talk about that at the end, right? And you can think of a public sector as enterprise that kind of overlap. And finally, in consumer as well. We had Eric Vink here talking about what we're doing on the CPE side. But it's not just that, it's also the consumer products. I don't have time to talk about all that, but we're looking at it across the board. On the service provider side, everybody knows this chart, right? But this is the one that got people moving about a year or two ago on the service provider side. It's the ISPs that are deploying IPv6, okay? This chart is not all that scientific. It was done by Ralph Drams. He basically went around the company to all the SEs and said, if your customer has a date for when they're going to deploy IPv6, whether it's a trial or production, tell me what it is, and created that chart. So you can just kind of see the plans for IPv6 deployment, and that drives things like this, carrier grade v6. So my friends over there helped work on it. This was launched last October, and it's really about what to do with IPv4 exhaustion. It's very similar to the work that you see in the IETF. You've got soft wires on the bottom. You've got behave up here at the top with a large-scale NAT, v4 to v4, as well as v4 to v6. Why did we have to do those kinds of things, right? One of the big reasons, at least on the wireline, is this. Let me actually flip to the next slide. That. The big red thing here. And I presented this exact slide at a RITE meeting a year and a half ago or something like that, and it hasn't changed much in the industry. The access networks, particularly IPOE, end-to-one VLAN, were designed with very IPv4-centric mindset. These are supposed to be layer 2 devices, but they're not. They're layer 2.5, right? And IPv6 simply just doesn't work through them. We went through a period, Ulay mentioned it yesterday. When we were in the PPP world, we understood multi-protocol. Then we forgot. And we rolled out all these new IPOE type technologies and didn't think about multi-protocol. And now we're in 2010 and going, what did we build? Oh my, right? Now that said, the PPP stuff kind of works, right? Because it was designed back in a time where we had multi-protocol. What does that mean? To get IPv6 to the home, how are we seeing IPv6 getting to the home? One-to-one VLAN IPOE, not end-to-one, one-to-one, so it's just a point-to-point link. This works. Dual stack PPP works reasonably well as well, okay? There are some problems. In particular, you heard some of this stuff yesterday with respect to the wireless. You also see this in wireline, where you end up when you enable IPv6, you end up with double the session count. And this is insane, okay? User sessions should be per subscriber multi-protocol in the architecture, in the way you sell the equipment and buy the equipment, in the way you operate it. The idea that you have to pay for 2 subscribers just because they're using 2 different stacks is really painful to IPv6 deployment. Oh yeah, and the other one, my last 2 favorites, right? Not really favorites. L2TP, we actually see this used a lot. It was identified in the Softwires working group as a preferred transition mechanism. It's really good for when you need to spawn a tunnel from behind a NAT. 6RD, you heard a lot of service providers adopting that as well. One of the reasons is because it just provides that minimal delta over IPv4 in order to get IPv6 deployed. Speaking of that, you hear me talk about free telecom a lot. I like to think of them as my personal test bed in Paris. They're wonderful to work with. They're a lot like Google. They just kind of, that's a good idea, let's do it. And that's how I get my IPv6 in Paris using 6RD up until, oh, I forgot I put a traffic slide in here. Guess what that is? Right. This is straight off of their stats, right, from their 6RD deployment. And one thing's changed. It's running on Cisco gear now. Instead of their Linux-based implementation, they've moved it over to our ASR 1K, running in production with their traffic, and that's going to be commercially available next month in our release 8 or whatever it's called of the ASR 1K. You can go out to the store and buy it and set up one for yourself. This is the ping party. It was a lot of fun going in there and setting all that up. These are that's the happy Cisco account manager. That's Ule. This is Ule. He was supposed to physically be there, but a volcano cloud got in the way, so we had to bring him in over Skype. And I got to do the fun part, which is the Port of Champagne. This is in Paris, after all. Quick moment on dual stack light. Okay. You hear a lot about dual stack light. I hear people talking about dual stack light makes IPv6 easier. Dual stack light is IPv6 heavy. It's a wonderful idea for when you can run your IPv6 network native IPv6 to carry the IPv4 over after, right? Think of it as less IPv4 to enable, L-I-T-E, okay? Its main purpose is to turn off the IPv4. So deploying dual stack light before you're able to turn off the IPv4 is jumping the gun a little bit. It's a little bit backwards. And I see people rushing to that when they're not able to turn off the IPv4. And I worry about that a little bit. On the mobile side, we've got all the standards and it all just works. You heard yesterday from a couple of mobile providers. When Cisco goes out and buys a company from the central architecture group, IPv6 group that I work in, we kind of step over and go, okay, let's see how their IPv6 is. It was fantastic with the Starent guys. You know, they even had the stories of, oh yeah, when we tried to deploy it for this service provider in Japan 7 years ago, and we wrote all this code, and then they didn't do it. But you know, they've been at it for a long time. They're following the standards, and they've got good stuff. So here's sort of the transition. I alluded to it with 6RD, with DS Lite. Okay, you start out. Oh, the colors are horrible here. Sorry. You get your double NAT in here if you need it for your exhaustion. Hopefully you will. Hopefully you won't. If you can do dual stack, fine. If you can't, something like 6RD, something like L2TP. And then eventually you flip it over and you end up with dual stack light. Okay? But notice all of these things are basically dual stack. Every single technology there, at the end of the day, the service to the home is dual stack light. I'm a little short on time, so I'm not going to be able to talk about this in detail. This is what everybody wants when they first start thinking about, okay, I'm going to deploy IPv6. I want a translator. And when we chartered this work, where'd Yari go? When Yari and I worked really hard on this meeting in Montreal, drew up a big circle, IPv4 internet, IPv6 internet, translator. And everybody in the room was like, yes, that's what I want. But it's impossible, okay? And so what you end up having to do is break it down. My IPv6 network to the internet, or my IPv4 network to the IPv6 internet in this direction or in that direction. Maybe you can use stateless, maybe you can use stateful. It gets a bit complicated, okay? If you have a very controlled environment, and I applaud the efforts of T-Mobile, the discussion yesterday. If you have a controlled environment where you can really watch everything, it becomes viable, right? But as a general service, like a subscriber line into the home, I'm going to give you an IPv6 only. It's not an easy thing to do today. Dual stack is far more viable right now. Bit about enterprise deployment, if I can. How am I doing on time? 5 minutes. So I had the different market segments. That was service provider, I want to talk a little bit about enterprise. If there's anything that's core to Cisco's business, we have a lot of effect on how the enterprise deploys things. And a number of our forward-looking enterprises have been doing IPv6 for some time. Like I said, we're constantly in telepresence with you guys, talking about your IPv6 deployments and parading all the PMs and business units in front of you and getting knocked in the head. But how are we going to get to how are we going to cross the chasm, right? So most of the enterprises that we work with today have some sort of mandate, or they have a bleeding edge visionary mindset. But how do we get to the mainstream? I think this is sort of a picture of how the mainstream enterprise is going to be affected. This slide is from a Forrester research study or what have you, and I've kind of populated with my own favorite little icons. But the idea here is we've got web-enabled devices, cloud-based services, consumer software, the consumerization of the enterprise, as well as the borders breaking down. And when you take that and you look at it and you realize how much stuff, it's hard to see in this, there's lots of stuff green there. This is all stuff that is either IPv6 now, or they made a public statement sometime in the next 6 months is going to be IPv6. So your enterprises have devices coming in, the cloud services turning on, et cetera, the borders breaking down, and there's a push and a pull, right? So as the internet moves to IPv6, the enterprise moves to IPv6. And perhaps the deployment strategy looks a little bit different for the mainstream versus the early adopter. And so our prioritization might look a little bit different. For example, we might prioritize towards the internet presence first, instead of just the router and switches core, routing and switching core, or what have you, right? But that's one thing that we're looking at now. We really think is going to be a major trend. So, reaching functional parity. Again, talked a lot about a foundation. Implementation strategies, targeted development, IPv6 by default. The ultimate goal was a quote from John Chambers right there. So, all of our devices, all of our applications, all of our services. Questions?
Hi, I'm Charles Perkins from Y-Chorus. I noticed you said that you had stateless v4 to v6 NAT, and you characterized the more, I guess, stateful or more general approach to as infeasible because there's not enough v4 addresses to cover the v6 address space. But there are.
I know you're
you know my question, and I just wondered if you would be willing to soften infeasible to at least not yet standardized or exploratory, because there are results that show that it's at least somewhat feasible, and there's flavors on even the IVI, which characterizes as stateless. You can have DHCP based IVI, and you can have some other gradations all the way into this source IP net, which gives you a really good, let's say, reuse of the v4 address space that you might assign to the NATs.
Yep. And Dan, are we looking at that? I've been talking to, last time I talked to you about that was about a year and a half or so ago. Is it the same idea? Similar?
The same idea with, you might say plus, because it turns out there's some additional, we have deep packet inspection, and if you use that, you can get some, well, I'll just say 100% accuracy on the translation from v4 to v6.
Okay, 100% accuracy. You'll have to tell me exactly what that means. If I remember correctly, the limitations, you end up in this situation where it still kind of depends on what your IP distribution is, the addresses that you're reaching and the addresses you're coming from. And if you get lucky, then it works great. If you get very unlucky, it could break down. But therein lies statistical multiplexing, right? So
that isn't, to explain it fully would take longer than you
right.
have and I have right here. That would have been my lightning talk yesterday. But suffice it to say, I think that it has advantages and disadvantages, and the advantage is that it eliminates that word infeasible from your slide.
All right.
And the disadvantage is, like any net, it's not perfect.
right? One of the things that well, Yari and I, when we were working on this, struggled with. We started out this chartering of the NAT64 kinds of stuff as let's just do it for these cases, and then the world pushed us into the general, and then we chartered every iteration, and then that's Dan's slide. He's telling me that's what Behave is focusing on, which is, like instead of every possible iteration, something less than that to get a focus, right? So that, as far as I know, for the roadmap talk, we're following what Dan tells us to do from the Behave. But I understand that there could be, pluses to this, and
Okay.
we'll see.
Thank you.
Yeah. So just to respond to Charlie as well, of course, you can do many things. We can cover all possible combinations and network situations. The question is not just theoretical; it's also what do we need to do or want to do. And just wearing my vendor hat now for the moment, I see a lot of demand for case one on Mark's slides here, but the other stuff is not in so high demand. So that sends one type of a message.
Mark, Matthew from Internode. We've got a global network here, and it's working pretty well. But what's our load balancers you're planning to run www.ipv6.com behind? And can you tell me what went wrong there?
Very fair. You know our weaknesses. For this www.cisco.com, I'm only one user. Not a problem. Manny, I believe that we will be having an open source SLB solution in the interim until we have our ACE products able to do IPv6 load balancing. And that won't come until second half of next year. It's on the roadmap. It's committed. We have some historical problems on the platform, but they're being addressed as rapidly as they can. New hardware is required. The new hardware is available in testing, so on and so forth, but it's going to be next year before we have the server load balances on the ACE platform. And there you go. But that's better than it was. It was even further. We've accelerated it to that.
Mark?
Hi.
Hi. So I'm sure lots of your customers that have deployed V6 already have V4 networks, and they do things for their business, like collect net flow for peering decisions or other business decisions or security reasons. How do I get V6 content in NetFlow? And when can I do that on my fancy ASR 1000?
The fancy ASR 1K, I believe it's
my
release 9, yes?
or
Release 9, 10, Kumar's telling me, which is like end of this year, end of 2010.
End of not now, right?
End of 2010.
I'm deploying now, though.
I'm sorry.
So my business is, at risk while this is happening, right?
Yeah.
So, we all knew we needed this data, right? Okay, I know you're not the guy doing it, but who is?
You're right.
Right. So today, I collect NetFlow off my V4 network, and it tells me this IP address talk to that IP address with this port and protocol this much time. But why would I want to do that? Now the next guy is going to have to pull it down. So I want to be able to do the same thing in V6, right? I need to know that this V6 address talk to that V6 address, through this. Yeah, just right, straight NetFlow data, but 128 bits for addresses instead of 32, which is IP fix, right?
You can do it on Nexus now?
On Nexus, great.
Great, you can do it on Nexus.
Right, I have GSRs, I have that fancy CRS1 that I put a new sticker on to make it a CRS3. I'm making a joke, but the point here is that the businesses have needed this functionality for the last 10 years. The vendors have known that V6 was coming, and the IETF declared it sort of a baked and done product when they disbanded the V6 working group. So this is all, it's all production grade, right? And I can run my business with this, right? But I don't have NetFlow, so I can't. So there's yet another barrier to deployment, right? Or at least Right. So
I guess all I'll say is it's a fair point, and I think different platforms in Cisco are in different stages of their roadmap, and so that's the only thing I can say.
okay, that's
and it's
fair.
in hardware, so
Right. So I think as a feedback to Cisco in this case, and I'll repeat this exact same thing when Juniper comes to talk. But instead of CRS 1 to 3, it'll be a T640 to T1600. So it's not quite a sticker upgrade, but the point is that everyone who's a customer of these vendors really ought to be saying the exact same thing, which is, hey, my business needs these things, just like my enterprise business needs DHCP sort of equivalents for V6. Not your platform, I understand, but anyway, thanks.
Thank you. Your customers have asked you.
Yeah.
Don't say your customers aren't.
Can
I
we,
never did.
Can we
His
cap the line here and
customers.
get things kind of quick because we need to get on to the next presentation.
Yeah. Actually, I'm done in terms of time. We're eating into Dave's time now.
Jim May.
Can I?
We
So
can talk about procedure for 10 minutes, or Jim May can ask his question.
okay.
Could you go to the slide showing the transition from not 444 to 630, then
This?
something? Yeah. So in terms of roadmap, do you have any plan about these things? As a
6RD
Cisco
on the
product?
ASR1K next month, on the CGSE Blade, the CRS later this year.
Uh-huh.
Dual stack is available on for PPP and 1-to-1 VLANs on our ASR1K today. I mean, this is just off the top of my head, right? That's the BNG platform that we have. The dual stack Lite is further out.
No specific plan.
No, it's a roadmap.
Okay. Okay. Thanks.
But yeah, the 6RD is more solid on the platforms that we're targeting.
I know it's in production.
And yeah. Okay.
He was first.
Sorry, Dave. I mean, I'm happy to sit down.
Just quickly, I guess I want to echo Chris's comment that I think we have to be careful when we talk about roadmap and feature, and this is not only to Cisco but to the vendors in general, that we build the feature set to make something deployable, because a set of discrete features is not necessarily gonna push a product out. And we're running onto that. I guess NetFlow is one case, Kalia is another, and so forth. So it's very important to pay attention to the collective set of features to make something deployable, not discrete features.
Yeah, when I talk about the deployment strategies, we identify a deployment model and identify those features within it. That's the idea. I mean, not every model is addressed, of course,
And
but
again,
that's
this is not
absolutely
only for
the
you,
idea.
but to the vendor community.
Yeah.
Randy Bush, IJ. Luckily, when I use a roadmap when driving, it actually has real distances on it. And when you say that hardware issues, what I hear is you haven't started spinning the frigging ASICs yet, and minimum 3 years.
The past hardware issues, and I also said the hardware is already available, and we're putting the new features on it.
128-bit TCAMs?
I don't know the details, Randy.
My packets know the details.
I can find an engineer that does. You should join our development council. Is that all? Thanks.
Yes. Thank you.
Thank you. Thanks. You want this?
Sure.
Dave Ward.
Hello, everyone. Good morning. I see you've all had coffee. Thanks, Mark. Thanks a ton. Appreciate it. I'm Dave Ward, recently to Juniper, and I was the one who put the sticker on Chris's new router. But anyways, actually, let me, if you don't mind, Mark, I'll answer Randy's question. Actually, TCAMs on the big boys are 144 bits wide. So big boys don't always help. Big boy routers don't always help everywhere in the network. But anyways, instead today I'm going to talk about what's going on at Juniper. Perhaps not so shockingly, the general trajectory of trying to get all products in the portfolio running the same feature set is the same general mindset that we're trying to accomplish as well. But because there aren't 42 million things in the order book, and because there aren't, again, 42 operating systems that need to be worked on at the same time, things are a little bit different in how the strategy actually ends up rolling out. Basically, although I can't channel JC himself to speak to us today in any kind of movie, basically it's the same strong commitment to try and build both IPv6 and transition technology. Where we're going to end up in this talk is that we realize that getting v6 out requires that there's coordination with the deployment of this transition technology at the same time. In addition, v6 is clearly a commitment with respect to seeing new features rolling out in every single feature across the portfolio as well. Also, there's a bit of a different mindset with respect to the duration for which hardware generally is being supported. And really what I'm trying to say is that the perhaps faster pace of upgrade of hardware and the ability to roll out ASICs, again, because there aren't 42 million items in the, and different variations of these platforms that need to be maintained, rolling out new ASICs for these platforms and reuse of these ASICs across platforms, you see perhaps a little bit more of at Juniper. In addition, what's critical in our mindset in trying to create this ubiquitous service is that, in fact, the end-to-end services across the portfolio are available, similar to what Chris was talking about or Nabil was just talking about as well. So let's just jump into a little bit. So what should be obvious from talks that were discussed yesterday, is that there's basically a couple of conjoined strategies that need to be discussed. One is the transition strategy on how to preserve v4 and v4 access, and the other one is, of course, attempting to deploy v6. Now, what's interesting is that even the technologies that were discussed yesterday, whether 6RD or DS Lite, again, do require a cooperation with CGNs and v4 transition technology. And what I mean by this is that you've seen over and over again in the presentations, and even the presentation we just saw, that CGN is embedded in DS Lite potentially, or is also potentially embedded in the 6RD deployment. So it's critical to understand exactly how they fit together and exactly the scaling parameters of these different building blocks that need to be put together. So in essence, in the bumper sticker version, is that transition technologies, whether they're translation, encapsulation, or what have you, are being built as building blocks that need to be able to be put together in various forms, in various orders, as are necessary as we begin to learn and understand how to deploy this technology. So the toolkit that we're looking at, again, is a bit different. The size of the organization is more than 10 times smaller than what Mark is trying to organize with respect to his technology to roll out. So we're able to potentially move a little bit more nimbly, as well as potentially move towards some directions where we're not sure, or the industry isn't sure, if they're all potentially going to work out. Not saying that we're living in the research realm, but we are willing to experiment a bit. There's others, and we heard presentations yesterday, of others who are willing to experiment in new directions to find out which are effective transition technologies and which are effective ways to deploy v6. So on the three axes that I put up here, there's no doubt that depending what's attempted to be accomplished, and again, we're looking at everything from translation back to transport core, these bits of technology are things that we're currently working on that are currently available. And so, yeah, it's a laundry list of stuff that you typically see, but perhaps even a few extra. And we're going to be rolling out a number of these different pieces through time. Now, most of what, and I think everything I've put up on this slide right now, except for the A+P PCP piece, is actually available. And so we're absolutely looking and trying to understand at how v6 and how transition technology is going to be deployed. And we'll talk about some data that we've collected off our boxes at the end. So some assumptions, and I think these are the same assumptions that were discussed yesterday, as well as most people have in this room, is that where do we need to get v6? Well, we need to keep subscribers. Sorry, I have a meeting in 15 minutes that I won't be able to make. That we need to be able to continue to bring on new subscribers, particularly wireline and wireless, of course. Also, regions outside North America and Europe obviously don't have access to the same v4 address pools and therefore need to roll out v6. And Brazil, Russia, India, and China certainly come to top of mind of rapidly exploding use of the internet and rapid advancement of a large number of subscribers being added as well. I think what's obvious, and John put up some stats from the work that they've done at Comcast, what's critical to understand is that today, even with Mark's singular advancement of the technology and being able to use v6.cisco, 0.15% of the top 1 million websites in the world today have v6 access. So we still need to obviously realize that even if we make all of the endpoints dual stack, the global internet, there's no games, there's no gambling, there's no girls, there's not a lot of places to go. So the v4 access needs to be maintained through the different types of transition technologies or translation technology. Clearly something to understand is that v4 addresses aren't going away just because you can't get /8s. Instead, deaggregation is going to be something that needs to be handled, and we heard some talks yesterday, and we know some technology that needs to potentially roll out. Obviously, rise of middleware boxes. We talked about the port connection protocol and the control and interaction that's going to be necessary to these middleware boxes, as well as the middleware boxes that we discussed with respect to firewalls, NATs, and other devices that are there. The last thing that I think we're going to find out is the next stickler, even beyond NetFlow, Chris, is going to be that CPEs need to fundamentally change. And there's a whole lot of tens of millions, if not hundreds of millions of CPEs out there that need to be upgraded, that need to be modified. And there's going to be deployment decisions. So if you notice in Mark's slide with v6 is turned on by default, transition technologies are going to be turned on by default by the CPE vendor. You now have an incredibly important deployment decision to make of how to handle the policies of which of these transition technologies you're going to be sending out in your DHCP advertisements, and how you're going to be handling the opportunity for your customers to all buy different devices if you aren't running managed CPEs. Therefore, what I'm trying to say is that when you go down to Fry's or Best Buy and you pick up a CPE, what are its defaults? What are you going to be advertising DHCP? Are you going to have asymmetric traffic running in your network? Interesting problems that we're going to be discussing next year here, hopefully. So what's a little bit different from what we're doing at Juniper versus at Cisco is that there is still one operating system that's running across the product line, at least the part of the product line that we're going to be discussing here. So running out of time, you have the slides. I'm not going to page through and read all of these bullets, but v6 in Junos has been around for a real long time, deployed in 2000, 2001. Operational tools, forwarding capabilities at line rate in MXM&T. Typical routing protocols that you'd expect with full policy enabled, basically extremely close to parity of v4 where it's possible. Same thing with multicast. One thing that's a little bit different here, and I call it out in yellow, and it's actually a challenge for the industry, is that the entire routing and signaling control plane at Junos, as well as the rest of the environment, isn't actually necessarily completely defined for how to work over v6, and certainly hasn't been implemented. Not only not implemented by Juniper, but by other vendors as well. So I've called out here that the MPLS control plane is typically the most challenged one, with RSVP as an example, or potentially LDP. So that means that the current most widely deployed v6 transition technology, which is 6PE, is running over a v4 control plane. If you're running it, you know that. If you attempt to run the entire control plane over v6, industry isn't there yet on any front. One thing that's interesting, and I mentioned this extremely quickly on the ASIC slide, is that the ASIC evolution that we're building is attempting to enable not only, of course, v6, which has been in for a long time, but move the ubiquitous features that we're currently seeing, which includes the 6RDs, NATs, translations, etc., directly into the forwarding plane. Tunnel cards, tunnel picks, which have been alive and around in Juniper routers and all routers for a very long period of time, are, again, centralized forwarding engines inside a router of limited bandwidth and limited scale. And now that these features have become ubiquitous, move them into the generic forwarding plane of the routers themselves. And that, in a bumper sticker, is the general trajectory forward. Move things that we can into the forwarding plane. But as long as I'm talking about tunnel cards, what's interesting about some of the work that's been done on the tunnel cards are perhaps some features that some folks are excited about and other folks are interested in investigating. In particular, NAT6, v6 NAT, v6 stateful firewall, NAT6.6. Exactly. But what's interesting about this ULE is that theoretically, we know that it's got pros and cons. Practically, we still need the experience to be able to do it. And as you know, if it's only software, and writing code on this is only software, let's find out how it actually operates in the network or in experimental networks. Do you want to interrupt me now?
According to your product manager, NAT64 is not available.
Code available today doesn't necessarily mean it's, I didn't mean to connote for those 3 that it's in a shipping release, but that's fine. Lorenzo.
6RD is also, I think, a year away, or at least that's how I was told,
on
MX.
It's available to some people.
Developers.
No. Even you, Lorenzo, if you'd like. So what's interesting is that there's a second approach, and Mark didn't touch on this, but it's something that has been discussed a lot in vendor space because it's an extremely challenging problem. And the challenging problem is how much HA do you need for this transition technology? We've discussed in the past at this conference and other conferences, taking a look at, and we're going to discuss even in my talk, what is the average number of sessions that an operator is using? What's the rate at which this stuff comes on? Do you have to open up 1 million sessions per second? Can it be 100,000? Whatever the case is. We don't actually know that much about how our networks are actually functioning, and certainly the session statistics associated with our subscribers. So what's interesting is toss up the SRX, which is one platform, and it goes from very small versions or small versions to very, very large versions. But what's different is that trading off scale with HA, the scale numbers that you can see here up to the tens of millions or over 10 million does include stateful redundancy. And so what's critical is we understand how the sessions and how our subscribers are using the net, for which I believe we have very little information, or it's been a long time since we've looked at this again. We need to understand exactly what this is going to mean. Do we need full HA on all these sessions? In this particular case, it was easier just to solve the problem, which was do full HA and be done with it. But we might find that things emerge if we continue along with centralized technologies. So the SRX is again the service appliance. It also has a roadmap, and it's moving down this chart of what's available today, both in product and some in the top prototype, and then moving forward in what's going to be available. Heading down the path of making sure that enterprise endpoints have the services they need, the security, the firewall, the intrusion detection, et cetera, that's necessary to be able to deploy this stuff. As Chris was saying and Nabil was saying, extremely valuable point. Not only are potentially are all the operational tools not available, but if you can't plug in your lucrative customers or important customers with the technology that they need, they are not going to be able to transition for an extremely long period of time. So what's interesting is that the SRX is the transition from the Screen OS, which is the ISG platform, which actually has all of this enabled today at scale, and moving it over to Junos. So again, we're trying to get to the point where there's a ubiquitous feature set of all these features across the operating system. Mark brought up a very interesting point, and I'm going to power through some of this so that way we have some time at the end to talk, about the necessity for IPv6 subscriber termination. So today, you can get IPv6 subscriber termination on Juniper boxes, including the MX. We've got a large number of pages. What Mark mentioned, which is critical, and I'm not going to walk through all these, what's critical to note is that he mentioned that a subscriber that's running v4 or v6 must have the same object construct in the operating system, both for billing, for management, as well as just for general overhead. Thankfully, that's the way the architecture works today, and so therefore you're able to roll out v4 and v6 subscribers, not have double the overhead double the overhead on the operating system itself. In addition, the way the architecture works is that the features that are available for v4 subscriber termination are available for v6 subscriber termination. So if you take a look at the BRES that's currently being shipped on the MX, terminate v4, terminate v6, toss in the tunnel card and have a NAT enabled in code that's soon available off the beyond just prototype and early beta release for 6RD, for DS Lite, for these different things. Put together these pieces in modular ways so we can find out exactly how to roll out the maximum number of our subscribers. You can read these slides at your leisure. I don't have fancy pictures, but I'm going to page through it because, as mentioned, to use time. Okay. So I've got my dark slide with odd colored font so that it's illegible as well, but it's my only one. So the point that I'm trying to make here is even though you have modular pieces that can be put together, whether encapsulations, translations, or other different ways of terminating subscribers, having enterprises, your vendor here is to remind you, as we've all been discussing over the last couple of days, there are things that we know work and there are things that we know don't work. It's my highest recommendation that you don't attempt to deploy the things that we know don't work. So we know, for example, and I kind of started off this talk of, again, a mix and match of technologies is critical to be able to deploy any of this stuff, that NATs and 6RD, we can handle V6 apps, the network can handle, not just Juniper, the network can handle V4 apps, V6 apps, dual stacks, everything you need to do with a combination of these technologies. Why? Because it's a combination of V6 access technology as well as private V4 addressing. But NAT 6.4 is going to be fundamentally limited. Your V4 application is simply not going to run over NAT 6.4. Perhaps this is overstating the obvious, but you really need to understand that NAT 6.4 is a solution for only specific network environments. It's not a ubiquitous solution. Perhaps, again, that's overstating the obvious. We know that any combination of, for the wireless world, again, of V6 access technology and translation technology is going to be able to work depending on the mix and match that you want. I'm not here to argue about which encapsulation is the better encapsulation. Frankly, we don't care in an implementation. We're putting all the encapsulations in, almost all the encapsulations, do you know? But also, with wireless combinations, rolling out NAT 6.4 again, you're going to be stymied on some of your legacy devices, or if you want to think of V4 applications, which are the predominant ones, legacy applications. Again, if you're only rolling out V6 handsets, you're going to be caught roaming in other, difficulty roaming in other worlds. Again, perhaps overstating the obvious by putting the two together, tethering your laptop to your new mobile CPE, which is your handset, is going to run into the same challenges. So remember, all the different network combinations of ways that people are seeking access out of the network need to be related back to the different combinations of technologies that can be put together for ubiquitous access for all these subscribers. So I'm going to finish now with a bit of data. And although we want to talk about V6, I've really tried to hit home that it's a combination of these technologies that are required, even in 6RD and DS Lite, which is to give us V6 access, has translation technology that's available. So let's look at some more data that we took, that we collaborated with a provider in Europe, directly off of our device, just to take a look at the order of magnitude that we're talking about. What's interesting is that, as I mentioned, we don't have a whole lot of data about our subscribers and the sessions and how they use the network. Therefore, when it comes time to talking to solutions engineers or attempting to provide a solution for how many NATs do I need? How many border relay gateways do I need? How many tunnel concentrators do I need? It's extremely difficult. Needless to say, your account manager is going to say you need a gazillion of these things, but it's much better to understand exactly how many you need, where you need to place them, and how they're going to interact with the rest of the network. So, relatively recent data, small font, May 27th, 2010 to June 3rd, 2010, the total number of flows. So you can see how many zeros there are here, place commas, in the millions and tens of millions. And you can see, of course, that it's spiking, time of day type stuff that you'd expect. Flows per category in different colors. What's interesting is that we're looking at the colors may be a little bit challenging, but the top one that's going up and down, that's the latest color is UDP. And you can see that it kind of skews the rest of the metric because everything else is fundamentally at a different level, which includes web, peer-to-peer, gaming, IM, and other TCP. So it's getting a little bit interesting. We've seen some counter data in the past about the importance and relevancy of UDP. But let's think now back to the HA question. We've gone down the path of saying on the SRX, stateful switchover of all sessions. Each one of these UDP sessions is consuming that state and consuming that performance and scaling. It's an interesting question to understand whether, or it's an interesting question to see if your solution you need for this. Next thing, let's take a look at the average flow consumption per subscriber. Rough same time period. This is May 29th to June 6th, relatively recent. That's not that bad. sitting on a NAT, you need to open up 120, 128. Sure, you can bump this up to 256 and double it if you want to have some headroom. But really the point on these border relays and tunnel concentrators, whether it's DS Letter 6RD that you want to plug into a NAT, what's the rough order magnitude that we need to figure out for scaling? How big is that NAT? And how many subscribers are we actually terminating through there? Number 120? I'm actually not that worried. Looking at the flows per subscriber, so we've got number of subscribers in this column. We've got number of flows, percentage and cumulative percentage, and you can see that, sure, there's some folks that in this range right here where you actually get into an interesting percentage and cumulative percentage, but nonetheless, only a small number of subscribers have an extremely large, where we're talking about 1K to 4K flows. Looking at that application, what we're looking at for UDP, which is always the critical question, what are these sessions? Again, take a look at this when you get an opportunity. It's on the web, on the agenda web. With respect to the UDP ports, yeah, of course, we're looking pretty much at swarmcasts and going out and finding, who's got the data, where's the data. Small, extremely small session flows, very few packets, very low bandwidth, and then the data starts flowing back mostly over TCP. What's not on here is session flow length or the total number of packets, which is another interesting variable, but there's only so much data that we can toss up at this point. Really, it's going to be interesting to trend this over time, whether or not these are the applications, these are the number of flows, is the flow count going up, is the flow count going down, etc. And I highly recommend that folks begin to analyze the networks in this way. Okay. In my opinion, the medium number of flows is actually low. 120, was expecting to see much higher. We've had, over the years of this conference, or the last couple of years of this conference, we've seen predictions that the number of flows is actually, is it 500? Is it 1K you need to allocate? No, it doesn't appear that that's the case. The other thing we talked about was the 512 and 1K was due generally to AJAX and, the Google apps, or whatever the case, that might use various forms of tiling on the web page to be able to construct it. Note that didn't really observe that, right? Maybe it's because they were instantaneously captured, but we captured all the data. It was interesting to see that we didn't see this massive explosion during these different events. Gaming, Teredo, surprisingly popular, okay. And the use of web streaming does seem to be a limited phenomenon in the world. So also ALGs are in use that we can get out of our stats, and that without having DPI or something similar, just based on port, really doesn't give you information into the data that's being collected. So when looking at NetFlow, Chris, wherever you sat down, NetFlow is going to be interesting. It's going to tell you something about what your subscribers and sessions are doing, but it might not be telling you enough to be able to understand how to handle the transition with respect to where you're going to place concentrators, where you're going to place NATs, how much bandwidth do you need, how much state do you need to hold on these devices. So we're going to finish up in just a sec. So no license required for V6. For attending this conference, you'll even get a discount. Last, so really just to sum, so V4 depletion and deaggregation of the routing table is going to occur. We're absolutely committed to building transition technology and fundamental V6 support in the ASICs, in the operating system, and maintaining that ubiquitous feature set across the portfolio. And clearly, deploying V6 alone doesn't address V4 depletion, doesn't address solely what needs to be done to keep connectivity available, but it's absolutely critical as a solution for the future. Thank you very much. Any questions? When can you get your software? Excellent, perfect.
I don't know, these talks have made me just so infuriated. It's like I don't even want it to some degree. But general feedback, both to Juniper and Cisco's at your support organizations. When I call them and tell them I have a IPv6 bug or issue, they're scared. They don't know what to do. It's because they're not trained. Double talking the slides, really don't like that. Code's not available to me. I'm doing a NAT 6.4, UMTS rollout in the United States, and it's not available to me. I don't know who it's available to. Control plane in IPv6, I'm not sure we need that so much. The issue is users and content. My backbone links, people may be asking for it, but personally, I don't see it. You put up a slide about less than 1% of websites having quad A's. Facebook, Google, that's 40% of my traffic, bandwidth and sessions. So you may look at the long tail of the internet. Yeah, the internet's really big, but I care about the ones that do the most sessions and bandwidth. So.
Thank you. Was Chris first? Chris, go for it. Lorenzo, go for it.
Okay, so you said earlier that there's no problem in the core because, well, there's a problem in the core, but the problem at the edge is much bigger because all these CPs have to be forklifted, and they don't. I mean, what needs to happen is that new users need to get CPs that do v6. I mean, the old users are just fine. They already have v4 addresses. They can keep using v4 until 2050 if they want, assuming there's still any content available to them. But if we do want to accommodate new users, we need equivalent level of support in the core and on the content side and the access side for those new users, right? For example, I mean, not to come back, well, actually to come back to the earlier point, I mean, if we need to forklift all our routers to get NetFlow, that's a problem, right? It's not like changing CPs for new users. We have to rip everything out and put it back. So, and I know that there are security folk here that are very anxious to get information about who's using the network, right? And we don't have an answer for them. So there are problems that we can't just gloss over.
Agreed. You like NetFlow, Chris?
Yeah, it's interesting that using your slides actually, the capacity planning information that you also would want out of the v6 network, right? So you use NetFlow derived sort of use and session data, very, very applicable to exactly what we want. And so Lorenzo's point about forklifting, it's very challenging. I mean, at Cisco, our Cisco folks had told us at previous jobs, you want this feature, you need to upgrade, just simply upgrade this card. You don't use this anyway. Like, I have 3,000 of those cards in the network. I can't just forklift those, right? I have X number of routers in the network. I can't simply replace them. So it doesn't make sense to me that a forklift would be required. So
why should I have to?
Well, I mean,
thank
is
you,
that
angry
a
old man.
self-answering question? I don't know. It seems like a self-answering question to a certain degree.
Yeah. So I think there are some customers, or at least one customer, who would like to speak to somebody in the development group at Juniper about why it is that the situation is the way it is and what we can do to get out of it. And then hopefully Juniper can go back and to the rest of their customers and say, hey, these features are going to be available in X time frame, short time frame, hopefully. Some code upgrade is probably fine. Everyone's planning to do that anyway, but hardware is a problem. So, but you know this, right? So the rest of your organization being Juniper.
Yep.
Thanks.
Uh-oh.
I heard about this NetFlow V something that's bigger and it's got 32-bit ASNs in it. Can we do the same thing or something? It's only a few more bits, right? So maybe there's some sort of irresolvable technical limitation of the ASICs that were spun, but it doesn't seem that much harder to implement a fixed frame packet format that's a little bit longer. Granted, implementing something like IPv6 and variable length, TLV stuff, that's a problem. Maybe the ASICs can't do it, but adding a few bits here, well, you know best, but maybe we can work out a solution that gets us 90% of the way there.
Okay.
While I'm waiting for the computer to boot and for Kawamura to get me his slides, I had a question about NAT66, and
sure.
I forgot my pitchfork at home. It doesn't fit in my car, but I mean, please, dear God, why? I've yet to hear an actually good reason for NAT66 that is not multi-homing. I understand multi-homing is a critical problem that needs solving, but otherwise, mostly they seem to be situations where people just have not thought about how to do it in a new way. They just want to do it in the same way.
Sure, that might be the case where people are confused, right? But at the same time, when we are in the code and you have an architecture which allows you to do the same manipulation on one address family or another, some code is easier than others to write, as long as the hood is up. So also, the folks who are asking.
Can you license it at like $1 million per flow or something?
Just to you.
No, yeah.
Dan?
So I have a presentation on NAT66 that we'll get to do this
kind of a
afternoon.
segue.
That'll be fantastic. I'm glad you left your pitchfork at home.
It solves all the problems you didn't know you had.
Yeah. Thank you, Dave. Thank you.
Thanks.
Actually, sorry.
I thought he was going to say something that he didn't. It turns out, if you want to talk about congruence and feature parity between IPv4 and IPv6, then you don't get to be picky about what you want to omit because you don't like it. So.
NAT66 is kind of a contentious issue, at least for some of us anyway. The IAB issued a recommendation regarding it, but Dan, if you have a second, I think we're finally ready. Sorry for the delay.
Cool. All right. Well, this is great timing. So who all's interested in NAT66? Everybody wants one. Everybody would like to have one, right? So I'm here with two hats. I work for Cisco. I'm also co-chair of the IETF Behave Working Group. The IETF's Behave Working Group works on NAT. I've been co-chair of that working group for a couple years. I have co-chaired a Birds of Feathers session at IETF where we discussed doing effectively a NAT66. What's interesting is everyone's reaction to NAT66 is, I don't want that. We had that same reaction to IPv4 NATs. We all have IPv4 NATs in our homes. There's probably 5 or 6 exceptions here, Randy, for example, of people who don't have NATs in their homes, but you don't have a residential internet connection. You have a business internet connection where you're paying for more than one IP address. A lot of people don't like to do that. That's the big reason people like to have NATs in their house. 802.11. Guests come over for dinner. They want to look at their movies. They want to look at their pictures. They want to download their email. But NAT66 is different. So the purpose of NAT66 is not to share IP addresses. I guarantee we'll have questions at the microphone talking about sharing IP addresses. But the only published specification for NAT66, which is down there at the bottom, does not share IP addresses. This is important to understand. So it's stateless. It doesn't diddle with or mess with TCP ports and UDP ports and all that kind of stuff. And it is stateless. So you can deploy many of them all over the place, and they can do all sorts of good stuff for you. And I'll talk in the next slide what all that good stuff is and why people are interested in NAT66. The right way to think about NAT66 is it rewrites the IPv6 prefix. And it does that to help out, do different things, get you onto a different network. The reason that a lot of people like to do NAT66 is they can't achieve one of the promises of IPv6, which was multiple prefixes. Because there's some very specific small deficiencies in the specifications and the implementations. There's some other reasons that people like to do NAT that I'll hit on the next slide, but some of these deficiencies are what are causing and forcing us to look at doing NAT66. So my talk here is to talk about some of those deficiencies and how we can get them fixed. So one of the reasons we are using NAT today in IPv4 is because we have hosts that only work well with one IP address. IPv4 hosts don't have all this source address selection and all these other fancy capabilities. They're generally kind of stupid. So the solution to that was, hey, let's throw a NAT in there. And this is one way to do a NAT, is what's on this slide here. Or one way to deal with this problem is to throw a NAT as the solution. That we can have a split between a tunnel going to a corporate network, which is terminating on a corporate network. This is terminating on the router, and a NAT going to the service provider. So this is where you are a residential subscriber at home, and you have a router that is providing a tunnel into your corporation. So this would be a telecommuter at home. And this is how this is implemented today. I have this at home. A couple thousand other Cisco people do, and we sell this to customers. And this works pretty well. You can add a DNS proxy into that NAT device as well, so that if you are making queries for Boeing.com or for Ford.com or for Cisco.com, if you're a telecommuter for Ford or Boeing or Cisco, it sends the query into the corporate network's DNS. And all the other queries going to CNN.com and Amazon.com and et cetera go out to the internet. So you can have a split DNS, split brain DNS there in the NAT. And that's because a lot of hosts can't deal with doing that themselves. So because the v4 hosts can't deal with doing that themselves, we do that in the middle. We do the policy in IPv4. If we simplify that diagram I had in the previous slide, it's really kind of this. This policy controller, this thing in the middle, the little router disk, decides, does the packet go up towards the NAT and towards the internet, or does the packet go down? And it can decide this by looking at DNS queries for the DNS proxying function, and it can decide this just by looking at the destination IP address for all other sort of packets, and then send them down into the private network and across the tunnel over the network. But the host doesn't see the difference between the complex diagram that was in the previous slide here and this simplified diagram. And my interest in showing this is multi-homing. This is the multi-homing that a lot of people say, gosh, I never do that. I don't have two ISPs. Who wants to pay Comcast and AT&T for DSL and cable? That's crazy. Well, yeah, you're not really doing that, but as soon as you start tunneling into enterprises, we start doing this. And also, as soon as we start having service providers offering some services, but not all, we start doing this. So an example is a service provider doing IPTV, or a service provider doing voice over IP, but they're not providing your internet connectivity. So they want some of your traffic, but not all of your traffic. And as soon as we're trying to get some of the traffic onto devices in the home, like a VoIP phone that runs 802.11n in your house, or TV in the bedroom, then we're trying to attract some of that traffic down into that private network that's not the internet. We're trying to get some other traffic up to the internet. So the problem is, how do we do this with IPv6? We want to do kind of the same thing, but we want to do it without this NAT function that we had to do with IPv4. That's the goal. How do we get that to happen? Because we can just put a NAT here and solve it exactly the same way, because everyone wants feature parity with IPv4, right? Except this one, we don't want this feature. So how do we do this without doing it? So here's the problems that are causing everyone to look at NAT 6.6. Are these really these three problems, and then kind of this fourth little nuanced problem, which is how to identify a host that actually supports these new features, these slightly tweaked features from what we have today. And then at the bottom in blue, yeah, it shows up in blue on my slides, are other reasons that seem to be very popular for people doing and considering NAT 6.6. I'm not talking about these today. Notice I put a line through the IP address sharing. So we're really hoping people aren't talking about NAT 6.6 because it's not helpful for that. And there's no spec, nothing written about how and why to do that for IPv6. But these other reasons, people are interested in doing NAT for these blue reasons. I'm just talking about the stuff on the top in black. So let's jump into some of the problems with source address selection. So the nuance here is that the RFC that we have, and a lot of the implementations that we have, but not all, don't do a good job dealing with multiple prefixes on one interface, and do a fine job with multiple prefixes on different interfaces. So as long as you have a wired Ethernet and a wireless Ethernet with different prefixes, a lot of hosts work just fine. Everything's okay. But the problem is the sub-interfaces, the virtual interfaces, whatever we like to call them on whatever OS we're running, don't seem to work so well. And when we pick the wrong prefix, as is shown here, the host picks the wrong prefix to go to the internet, so it picks the top prefix, the 1000 prefix, and sends it up into the wrong router and goes to the wrong ISP, source IP address filtering will drop that packet. And we want all the ISPs to do source IP address filtering, and they want generally they all want to do source IP address filtering. So the traffic goes to the wrong ISP. Now remember, everyone comes back very quickly when I show just this slide and says, yeah, but I never multi-home. I mean, that's Comcast on the top and that's AT&T on the bottom. I would never do something crazy like that and spend money on two ISPs. Well, remember the simplified diagram I showed before. This happens when we're doing tunneling. The other problem is if I'm connected to an ASP, so someone providing some application to me, IPTV, voice over IP, something else that's not really fully connected to the internet. And it's a very similar problem as before, but there's a subtle issue here that if the destination address happens to have a longest prefix that matches the wrong source address, just due to how the networks were numbered and when they got their network numbers, we can route to the wrong place. And here, of course, source address filtering could cause the packet to get dropped, but even if there was no source address filtering, there's no connection from that bottom network back to the internet. So it fails again. Another problem is next hop route selection. So the previous two things we're trying to get to networks that are connected directly to the ISPs. Here we're trying to get through a network. We're trying to get through our corporate network and go across this tunnel again. But our corporation has partnered with someone else who might be delivering training, outsourced HR services, IPTV service as part of the training or as part of a feed like a Bloomberg feed or something like that. And we want our packets to go there through that tunnel. The difficulty there is our poor host, way back there on the left, doesn't know the IP addresses of that partner network. And they'll just take the default route and try to go up that red path up through the internet and into the partner network. We don't have a good solution to that other than, make the corporate network also have IP addresses for all these partners, which causes address leakage. The way we solve this today, it's with NAT for IPv4. So we'd like to avoid having to do that again for IPv6. And the last problem is split zone DNS. So here's where we run into some issues where querying different DNS servers, we get different answers. A lot of enterprises love to do this. A lot of ASPs love to do this because there's a feeling that if I don't respond with the IP address of hr.example.com, if I don't tell you the IP address of the HR server, then I can't be attacked, or it helps hide my network. And this is just how people deploy networks. A lot of people don't like it. Shouldn't have split horizon DNS, but it's there. It's how things are deployed, and it's one of the things necessary to get all this stuff to work is to have support of this. Again, in the host, we can do this DNS proxying in the router if the router is terminating the tunnel. Well, we don't need to have to rely on that. We don't want to have to terminate the tunnels on the routers. We'd like to kind of terminate the tunnels on the host sometimes too. So then the last problem is, let's say we fix these things, the source address selection, the next hop route selection, the split zone DNS. If we fixed all these in the specs, they're not really hard, but if we fixed all these in the specs and then we fixed them in an implementation, how does the host know that host supports all these new fancy things? Or it's a printer that I bought last year that doesn't know how to do any of this stuff. Or it's a host that doesn't know how to do this stuff, Windows XP, for example. How does it know if it should give the host two prefixes and trust that the host is going to do all the things right, or know that the host is effectively too stupid and it's going to do things wrong, and I need to enforce the policy? And by that, I mean I need to run the NAT66 to enforce the policy for the host, on behalf of the host, because it won't do the right thing. So the last problem, and that was the parenthetical problem I had earlier, is I need a way to determine that the hosts know how to do the right thing. So I don't need to have the NAT66 hold their hand and help them. This sort of outlines the scope of the new work that seems to be necessary in the standards bodies and would be necessary in implementations to get all this to work, so we can avoid doing NAT66 for those reasons I listed. Again, I have those other reasons I listed in blue that are other reasons to do NAT 6.6. That's a different discussion and a different analysis for how to avoid NAT 6.6 for those reasons. So the purpose of the draft that we wrote and the purpose of my time here is not, this is how to solve it, but rather there is activity going on in some working groups in IETF that is necessary work so that we can avoid NAT 6.6. And I'm here to instill some fear in everyone. Consider your pleasure with IPv4 NAT and your desire to avoid NAT 6.6. What's important to avoid it is not to cover your eyes, not to cover your ears, and not to cover your mouth, but rather to take action and help this stuff go forward so that we can avoid NAT 6.6. It requires more than saying, no, I don't want NAT 6.6. Requires understanding why people want NAT 6.6 and helping this stuff go forward and demanding that vendors solve these problems too. Questions? It's very quiet in here now.
Hi, Bob Hinden from Checkpoint, and we co-chaired the BOF. So a couple comments, and I had seen your slides earlier, so I'm not commenting on something I asked you to change, I think. So the thing you said at the beginning, home users don't want NAT, they just get it, and they just want a network that works. There's a bunch of small home offices that would do it, and large companies just do the, they get PI addresses and run BGP and all is fine. V4 and V6 work the same way. And I think, I certainly agree it's important that we solve this problem because it'll bring multi-homing to a lot of people. But the other comment I had is, and this showed up in someone's talk yesterday, so there's what I'm going to call the way Cisco does VPNs, at least for their employees, where the VPN is done in a router and not the host, I think, but where the traffic is always sent down the VPN. I mean, I run a VPN like right this instant that knows the addressing domain of stuff on the other side of the VPN and doesn't send everything up that way. And so some of this problem is a implementation policy choice. It's not a protocol problem. Because we have working examples of both things. So it's not necessarily, and so that form of multi-homing, at least for what I run, works perfectly fine.
Okay, I backed up to slide 4, and slide 4 is exactly the sort of VPN service that I have at home with the equipment that's provided to me by Cisco.
Right.
This is different than what a lot of people like to have configured. Some enterprises like all the traffic to go into the enterprise so that they can scrub it for bad JavaScript,
for sure.
Right. Things like that.
But there is sort of a policy decision. And the last comment is that I think that some of the problems you pointed to about, outsourcing services, if those services get global addresses, so they're not in the same net 10 domains like happens in V4, then it really doesn't, the packets will get to the right destination and come back. Then it really doesn't, the packets will get to the right destination and come back.
It's not just optimum. Let's look at slide 9. It's not just optimum. Let's look at slide 9 and also slide 10. That X is not there to show that that's not optimal. That just doesn't work. ASP-B doesn't connect anything. It doesn't connect to the internet. So if I happen to choose the wrong source address, which does happen on shipping major operating systems, we go to the wrong path.
Wait, but so why wouldn't it be connected to the internet? What's the point of it?
It only runs IPTV. They are not trying to serve content to and from the internet. Their service is not internet connectivity. They're trying to just do IPTV.
Isn't that broken then? I mean, they should be serving it on the internet. It's IPTV.
You have an ISP. It's the one on the top that's connected to your house. Yeah, this is exactly what happens at NTT. This is also exactly what happens at major cable companies in the United States.
Right, but doesn't it just work if that private cloud has global addresses and you make a routing decision, then it would go there if you have a route, and that's a longer prefix?
They don't want to. They don't want to connect to the internet.
Source address is also a destination address. We got to deal with that side of the problem too.
Oh, okay. But again, I am in agreement with you that we should try to solve these problems. I'm not trying to sweep them away, but
cool.
We should try to not have to do everything. There's ways of doing things that may avoid some of them.
Right. My hope with this presentation is to show this doesn't just happen with crazy telecommuters at home, but this is happening with people with ASPs and non-internet connected network connections. Should.
Sorry about that faults. Then but anyway, I have some minor technical connection. You say that NAT66 is just a prefix replacement, right? But actually, we've already tried to implement some NAT66 in my lab. Then we found out that we should use the Margaret Busman's the proposal, the checksum free conversion. Then otherwise, if the packet is going to be fragmented, every single NAT66 device must have the recalculate TCP and UDP checksum, right? So you say that very simple notion is just a prefix replacement, but actually we have to modify also the
It needs a very specific prefix, yes.
Yeah.
In order to be checksum neutral.
Yeah. Or modify the 64 bits, the interface ID part.
Right.
So then we should talk about that too, maybe. Then because that goes rises in another problems.
Yeah, but I was spending my talk here about how we can avoid NAT66, not how we can do it better. And we can do it better, and there's a bunch of stuff that we can improve, and there's stuff that when we do NAT66, because if we can't get these hosts changed real soon now, we're going to have to do NAT66 in a lot of networks. Yeah. That's just it. We have no other way to do this policy.
Basically,
we have to do it better.
I really fully agree with that in your proposal, so that make new hosts can accept to prefixes, and also we really need to think about that router advertisement, I think. Because if we simply use a lot of advertisements to give the multi-prefix to the people, even older staff receives the new two prefixes by natural work the specification, right? So towards the new host you proposed, maybe we have to have the another mechanisms to give the another prefix to the new type of host, right?
Right. So that's that fourth problem I put in parentheses. We need to identify, is this a new supporting host that understands how to do all this stuff right? Okay. Or is this an old, stupid host that doesn't?
Yeah, then we have to be careful about all the stupid hosts can receive multiple prefixes.
Yeah,
still.
They will probably fail when given multiple prefixes.
We really need to have a very good backward compatibility.
Yes, agreed.
Thanks.
Agreed.
So I'm not going to talk about NAT66, but I'm going to talk about...
cap the line?
Did you want to say something, Eric? Okay. So I'm not going to say anything about NAT66, but I do want to talk about the problem. It's been proven over and over again that multiple addresses on hosts is a very complicated thing. The complexity of the solution is like over the top. Okay. So don't change the host. Yes, they have disadvantages as you stated. Give them one single address. The one single address identifies the host, okay? They have a locator, that's the public internet, and they have a locator that's in the VPN. When somebody wants to talk to them from the VPN, you give them the locator for the VPN. When somebody's global, you give them the locator associated with the internet, and that's it. We have this working.
Thanks to you.
Suresh Krishnan, I just had a comment about one of the stuff you pushed off as a kind of not main topic, which is renumbering, and I thought the blue topic, yeah. So avoid renumbering seems to be one of the major reasons people are asking for NAT66. So I would like you to put it in the main category rather than a peripheral category, right? And the reason I've heard for this is that there's a lot of systems that need numbering, which doesn't change when somebody changes ISPs. So there's a lot of provisioning system, backend systems that have addresses. Okay, so if you put it in the main thing, we can like think about how we can use like ULAs or something along with global addresses to keep the addresses same and the provisioning systems and everything. So I just wanted to move it to a primary goal instead of like a secondary goal.
Okay. Okay, I'll consider that. Thanks. Thank you.
Thank you, Dan. Quick.
Sorry.
One more. Hey, Dan, Steve. Quick question about the problem set you're looking at. The slides you have here, take a look at things from the client or the data failures. You have to consider the return path. So in the direct access case, we want to have a deterministic path out of the enterprise. Have you looked at that problem?
Yeah, it's tied into this whole thing because looking like at slide 8, for example, if you pick the wrong path going out, you'll even if you don't get filtered, the path coming back would go up. So if let's say the ISP at the bottom was not filtering and instead of showing an X, it actually went through ISP-B, it would come back through ISP-A.
But what I'm talking about is actually the enterprise edge. So needing to exit the enterprise at a specific point.
And exit the enterprise at a specific point and have return traffic come to that same specific point.
Right, for application inspection, that kind of thing.
Yes. Yes, very similar problem. Yes. I mean, imagine sticking your application inspector down there at that bottom router and then the return traffic is coming back. It's nearly the same problem.
Matt Mathis, longtime IETF participant and a new hire at Google. I wanted to point out that there's sort of an architectural problem here, and prefix rewriting has actually been on the table for the next generation IP, as it used to be called, for a long time, because it was understood that the scope of the prefix is really the organization, not the host. And there's an architectural problem that the host has to know its global prefix. And I think calling it NAT66 causes more bad karma than calling it prefix rewriting.
Agreed. Completely on that one.
As an architectural feature, prefix rewriting is not such a bad thing.
If we had a way for the host to know what that prefix was going to be rewritten to or could be rewritten to, and there's proposals for that,
right?
We could solve a whole lot of problems. Yes.
Agreed. So I'm not disagreeing that we should not fix the other things as well, but trying to comparing it to NAT 4.4 is probably not a good thing.
Agreed. Thanks.
Thank you, Dan. Thank you. Maz.
Hi, this is Yoshinobu Matsuzaki from IIJ. Today we're going to talk about the path MTU discovery failure cases. So go fast as possible. So as you may know, we can use path MTU discovery to take advantage. It's a big size of packet. So this is a path MTU discovery scenario in general. So right side host want to send data to left side host, and the host has no clue about path MTU. So the host send a packet, a big packet as possible to the network, but on the network we have a small, we have a link that MTU is a little bit small, so the packet can't go through the link. The center router then discard the packet and generate an ICMP error and send it back to the sender. And then the host realizes the more suitable path MTU and resend data to the network. So it works. And the key is ICMP. So first case, incapable. A router can't generate ICMP errors or a host can't handle the ICMP errors. Either case breaks path MTUd. This is well known. And the second case, filter. The router generates ICMP and send it back to the sender, but somewhere the ICMP error is blocked by careless packet filter or clueless security policy. This is well known as well. And this is the last case I'd like to share today. So I have two questions here. How often can a router generate ICMP errors? And how many networks put rel limit for ICMP? We don't have such kind of a traffic limit in our network, but I heard some networks deploy ICMP rel limit in their network to protect something. Though I don't get the point. But anyway, there are. And talking about originating limit, let's assume on left side, we have a consumers. Okay, can I use a row here? Yeah, we have consumers. And this router is a consumer aggregation router that terminate PPPoE or tunnels, tons of tunnels. Then the user try to access website on right side. So this central router responsible for generating or originating ICMP error to support PathMTUD. Do you know your router's performance about this? Okay, here is a configuration for that. And these are default value for the limitations. So Cisco router can generate 2 packets per second for IPv4 and 10 packets per second for IPv6. It's a little bit small. And for Juniper, they have a 1,000 packets per second limitation for ICMP. But this is for whole ICMP, so including pings or whatever ICMP. So is it enough for us? I don't think so. So summary of failures. The PathMTUD could fail even if all of given devices supported. There are a lot of issues. And I feel people consider the PathMTUD as exceptional handling. Actually, we are focused on the forwarding performance or routing performance or whatever. But we need to care about PathMTUD as well. Here is the data from a production network. So I gathered the TCP SYN rate on our consumer aggregation router. So peak is like a 10K PPS. And I think in these days, recent clients support PathMTUD for IPv4, IPv4 TCP. And it looks working. Does the router have enough capability to send enough ICMP errors? Probably not. Users don't rely on ICMP in the IPv4 network because almost all broadband routers have a TCP-MS hack, and it chokes TCP-MSS on a tunnel link, PPPoE or whatever that links MTU is less than 1500. And this avoid unnecessary fallbacks. And it's working fine. No complaint from customers. So do we need similar workaround for IPv6? There are two possible options for IPv6. One is MTU notification by RA. So in this case, IPv6 node can set a smaller MTU for IPv6 packet, but there could be a side effect. This reduces whole IPv6 MTU on the link, so bad performance of file transfer inside or on the inside of the link or on the link. And another one is a TCP MSS hack by broadband routers. This works for TCP only, but in these days, almost all traffic are transferred by TCP, so it could work. My suggestions are broadband vendors to implement the TCP MSS hack for IPv6 as well. It's dirty, but still it works, I think. It's dirty, but it works. And of course, MCU improve support passivity. Question, suggestion, comment?
I want to mention about two things. The first one is that from my experience about ICMP dropping, that happens not always intentional, but from my experience, some ISPs are deploying URBF, and some ICMP basic error messages have kind of wrong source addresses, not appropriate source addresses. That is, in my case, that they use IPv6 mapped. IPv4 mapped IPv6 address, so they drop those messages at URBF.
That should be an easy bug to fix.
Easy, but I mean they
tell the vendors and we should fix it ASAP.
I see. Yeah. And another thing I want to mention is that about the TCP issue is especially. The RFC 2923, I remember, recommends to implement the MSS fallback. If the TCP connection chokes, it recommends to decrease the MSS to the 1280. So, and modern OSs like Windows already implement that function. So it doesn't be such a big problem right now because of that function, I guess.
Okay, thank you.
Thanks, Dan. So, Maz, I want to add to one of your path MTU problems. So, I think there's no dispute that we'll probably be encapsulating IPv6 packets in IPv4, and there's probably going to be somebody in the middle of the tunnel that's going to want to send a too big message back. But the problem we have with IPv4 is only 64 bits of payload is returned from the original datagram, where IPv6 did it better. So, can you ask the vendors to, I think there's an RFC, Thomas might know about it, or Bob might know about it, where there was a proposal for IPv4 ICMP too big messages to contain the entire datagram. That would be useful because the tunnel encapsulator would have to do some caching and remember stuff. We have to do this sort of thing with trace route, which is a lot easier to do if you want to build a cache. That's kind of broken too. But with these sort of path MTU problems, there's real live streams of data coming in. It would be nice if we could make IPv4 ICMP too bigs carry more data in it. That would be really, really important.
Okay.
And if anybody has any comments or any users think that's important, please come to Cisco and Juniper or whoever and pound on us really hard.
So I suffered some path MTU problems on V6 for half a day. I'm curious if the statistics and analysis gathered by Google and by Yahoo are doing any analysis of path MTU problems. I know that there was a problem inside of Google that was reported on the .de V6 ops list like 6 or 9 months ago. But what's more interesting is where there's problems with all this this fun tunneling stuff. Because NATs are great, but you know it's this tunneling that causes these problems.
answer, not yet. This is something we plan to do. We can't do it because of a bug in the Linux kernel. So in particular, if your Linux kernel has two interfaces and it receives a packet too big on this one and it's sending packets out on that one, it ignores it. So we're sending out 1280 byte packets. So we can't measure it. We do have plans to measure it as soon as the bug is fixed.
Thanks.
Stana Gunnarsson, Google. It would seem that even if PathMQ actually works, I see it does break. It's really slow, right? Because the packet might have to travel all the way across the world and get like, I mean, if it's at the edge, it's not a big problem. You can rewrite the MSS or whatever. Do you think we somehow could move this knowledge about my MTU over here is slow, like all the way closer to the user? For instance, just like randomly say an MSS option in BGP.
Not sure. Need to consider about security, I think.
Sure, because I mean, you don't really want 200 milliseconds added to every single connection to a new host, right? And the caching here is single host only.
Yeah, could be.
Can I respond? So what we're trying to do with Lisp is we're doing RLOC probings between the encapsulator and decapsulator. We can make those large packets and do PathMDU discovery at the control plane before user data packets come. And then for each map cache entry, we know what the effective MTU is between those 2 points.
Okay, thanks.
Last question.
Hey, my name is Stefan Lagerholm from Secure64. I have two short questions, comments. First of all, I'm concerned about security. If people tell me to open up for ICMP packet to bigs messages, I don't know if I want to do that. First of all, there's a bug in some old version of Mac OS that crashes the Mac OS if you send an ICMP packet too big that's specially crafted. Second of all, this can be used as a control channel for some botnets or something like that. Wake up a million bots with just sending out an ICMP packet. So from a security standpoint, I don't understand anybody would do anything other than 1280. But so that's one question. Another question is this? I heard a lot of talks today about using link locals to do routing between routers and stuff like that. And can you really do that when you have this ICMP packet to bigs messages going back? I mean, don't the routers need a unique global address to be able to send those ICMP packets back? So that's just a question for the whole. I don't remember who talked about using link locals for routing, but I don't see how that's going to work in a real scenario.
They can have a global on the loopback address, right? You just assign a global address to the global unicast address on the loopback interface.
Say again?
You can assign a global address on the loopback interface of the router.
Okay, and that's going to work because I mean you get the address, the packet's coming in on that particular interface. It's not coming in on the, I don't know how to it's going to work. Mm-hmm. Okay.
Thank you, Tim. Thank you, Mass. Last but certainly not least, Kawamura-san. 5:10? Okay. 15?
All right. Hello, everyone. My name is Seiichi Kawamura. I'm from NEC BIGLOBE. Oh, I'm from Japan. I know everyone wants to go for a coffee break, so I will try to make it short as possible. So what I'm going to talk about today is NEC BIGLOBE is an ISP in Japan. It's one of the largest ISPs, and we're trying to turn up all our services dual stack by down to 2011, and we've been doing a lot of work turning up IPv6 and inner backbones and pairing links and everything. But most of our troubles that we had that we're having turning up IPv6 and access lines like FTTH DSL is mostly a political problem for us because we buy wholesale from like NTT and other DSL providers. But we have servers and like mail services, web services, portal sites that we're turning up IPv6, and challenges there were mostly technical. So I'd like to share the problems and the limitations. Oh, since this is a limitation session, that I should call it limitations that we experienced, and that's kind of what I'm talking about today. And just a brief explanation about BIGLOBE. It's ACE number 2518. We're on PeeringDB. Oh, by the way, I'm a network operator. I do like BGP operations and stuff. I'm not really a server guy, but I'm going to talk about those kind of stuff today. Our main business is residential broadband ISP. We have about 2 million customers in Japan. We have a portal site, www.bigglobe.nejp. And we also do ASP hosting for enterprise customers. And we also make mobile appliances these days. We just started doing this. Actually, this runs Android. So I guess that's IPv6 enabled. And our plans, I just said earlier, we're trying to make all our services accessible via IPv4 and global IPv6. So I'm not going to talk about these, the residential broadband ISP stuff and mobile appliances stuff today. It's going to be mostly about servers and application stuff and the troubles that we went through. So the limitations were basically 3 points: data center networking, email services, and portal servers, and operational needs that we had to go through. And here's a basic IP, what we have in our data center networking. It's very simple. This is a simple diagram. There's 2 routers, router 1 and router 2. They run VRP. They're configured with the global address. We have a load balancer, and there's servers behind the load balancer, which I forgot to draw. And the internet is on the top. Sorry, I didn't draw that either. And we have a management network on the side that's monitoring and pulling the router's global addresses as well as the VRP VIPs. So when we turned up IPv6, which was several years ago, the first problem we came across was VRP. VRP could only be configured with a link local VIP, and voila, the problem was the load balancer we had could only be cannot be configured to have the next hop set to a link local address. So the load balancer could not get to the router, and that was the end. So no redundancy. And we had to go with no redundancy for a while until that got fixed. And another limitation that we had to go through was we wanted to monitor the virtual IPs, but we couldn't do that because it's link local. So those were the 2 issues. There are many broken mailbox implementations that we came across. Not being able to set a link local addresses next hop is kind of a disaster, I guess. And most VRP implementations, VRP IPv6 implementations, only have link local addresses as virtual IPs. And RFC, well, I've discussed this with these load balancer implementers, and some people told me that, but the RFC doesn't say that you must be able to set the next hop to a local address, but that's. And the VRP RFC does not mention anything about handling global addresses. It's basically, I think, based on link local, if I'm not mistaken. But ISPs explicitly, we wanted to monitor the virtual IPs because that's what we do with IPv4. So we wanted to do it with IPv6. So what we did was, we asked for a fix on the load balancers, and we got them fixed. But we had to get rid of some because some of the versions cannot be upgraded. As for VRP, we did ask for a global scope virtual IP to be implemented, and I think it's being worked on right now. So that was it. That's the data center networking. And then we turned up IPv6 on our servers, and then we wanted to put Quad A's on them because we wanted traffic coming to us via IPv6. So we tried to do it on our portal site and our mail service, these www.bigglobe.nejp and mail.bigglobe.nejp. Mail.bigglobe.nejp is a pub server that serves millions of our customers. So we turned up IPv6, and a lot of things went wrong, really. And for the portal site, we set Quad A on just a portion of the website, and then instantly we saw a 5% loss of page view. I think there was a talk about yesterday about how brokenness would affect you does depend on what kind of customers you have, or how big your customer base is, and what kind of environment you're in. So that's the figure we got. It doesn't mean another ISP in Japan will get the same figure, but we got a 5% loss, and the 5% is pretty big for us. So we had to revert it back to raise it quad A. And for mail, we set quad A on the same domain, mail.biglobe NEJP that we were using with IPv4. 10 a.m. we set it. 5 minutes later, phone starts ringing and won't stop. And after about 2 hours, we had to raise quad A again. So what went wrong there? The bad ones were the MUAs, the mail clients. Even the highly popular ones behaved pretty badly with when quad A was fed to them. And enterprises have these customized mail clients that work together with other applications, and those just cannot be fixed that easily. I'm not really a fan of these customized mail agents, but that's what people use. So that was a problem. And we did this last October, and back then there were still virus scans that just drop quad A's and become silent. Those were problems too. And I think another thing that really hurt was poor quality, or walled garden networks, and these distant unmanaged tunnels really drops things. So those were the kind of things that went wrong. Well, we knew something bad was going to happen, but we didn't think it was this bad. But why did we do this? We've been doing IPv6 trials for a long time. We got our prefix back in 2001, and we started doing trials in 2004. And we've been doing lots of different trials for years. And it's just hard to catch real life problems doing trials. So we just wanted to stick in, get the numbers, and back out and think it over. That's kind of what we did. And we've also been doing IPv6 dot whatever domain for years, and we really didn't have too many problems there. So we really wanted to test that, but that's not what we're after. So we wanted to test what's going to happen if we put IPv6 quad A on the same domain as we have on IPv4. And testing a site that has millions of page views per day does give an actual figure. So that's kind of what we did. And with so we got IPv6 running on our services, and I got a chance to talk to people from our NOC. Those are the people that work 24/365, monitoring our servers and routers. Well, they gave me a lot of complaints. They say monitoring targets have nearly doubled, and that means they have more alerts to watch out for and more things to check out when something goes wrong. And logs are a nightmare because address representation is very different on different implementations. Like, for example, here the address on the left and the address on the right are the same addresses, but when you grep them, they're different. They don't come up. And also, many tools still are not IPv6 ready, especially ones that cost money. Open source ones are really working fine for us, but the ones that we paid for haven't been really fixed yet. And also, difference in commands have been troubling these are not people. For example, when you want to check out MAC address of a neighbor, you type arp-a for IPv4. Linux says IP-6 nay show. That's a pretty long command. And FreeBSD says ndp-a. I mean, it's kind of hard to remember all these commands. When with IPv4, it's just ARP. So operation is still not really that easy, but things are getting better. For example, the log parsing. I wrote a draft. It's in the RC editor's queue. I think it's going to be published pretty soon. And most open sources run pretty good IPv6 stacks. I think we need more work on those ones that cost money. And also, better operation quality means better service quality. So we need more operational practices. That's what I think. So here's a summary of the lessons that we learned. Broken implementations are still out there. We need to get them fixed, especially the commercial efforts. We need more of them. Open sources have been doing really great. And dual stacking over a single domain name is what we're after, and that's going to reveal real problems. So I encourage everyone to try it out and see how many percent what problems that they'll have. And also operational issues, I think, should have more focus. And I think this draft is pretty close, written by Brian Carpenter and Shen Jiang. It talks about ISP scenarios and turn up IPv6, what RFCs they should read, and what problems they would come across. And those kind of bad stories need to be shared so they can be fixed. And I think that's it. Thank you. Questions?
MUA problem? Yeah. I know.
Oh, this one.
Yes.
Yeah.
I just curious about what kind of problem with Quad A. This is about the POP client, right?
Yeah, POP.
So my
POP and TP.
general understanding is that there should be basically nothing special about Quad A for this type of application that generally use the generic resolver library or something like that. So that should be, it should be no different from other normal applications like web browser or something. So I was not sure what's special in MUA in this case.
I can't yell out the names in the microphone right now, so I can kind of whisper it to you later on. But there is a difference. Some mail clients get fed Quad A, they just stop.
Okay.
When if it works perfectly fine with IPv4, but when
so somehow that exists.
Yeah, it exists, and it's you'll probably notice it when you start trying a lot of mail clients. Yeah.
Last two questions. Oh, Bob.
Bob Hinden. So the thing you said earlier about VERP and load balancers or something.
Yeah.
I mean, so if the load balancer, if it can't talk to a linked local address, is completely broken.
Yes.
Because all of neighbor discovery works with linked local addresses, and so
it is.
There's nothing wrong with VERP or anything like that.
There's nothing wrong with it, but it would be nice to have a global virtual IP address along with the linked local. I mean, we're not asking it to be a must, but
VERP,
yeah.
I mean, at least
VERP
was designed to sort of make neighbor discovery redundant, so it followed the same model. So it's, again, the load balancer is just broken.
Yes, that's correct.
Yeah, I just have a stupid little comment, but IP space N is a short alias for IP neighbor show, and it shows IPv4 and IPv6, so it's just an education thing.
Yeah.
The same thing with netstat, you can just do -6rn, -4rn.
Yeah.
It's just a habit. It looks like if your support personnel or your networking guys had a hard time figuring this out, they should have been educated in this and had a habit in this.
Yes, education is a problem too. Yes.
We had lots of discussions about that yesterday.
Yeah. Good point. Thank you.
Thank you.
All right, thank you.